Okay, so we're in chapter 4 here, and we're looking at question number 7. The problem asks us to confirm that it's a probability distribution first. If it is a probability distribution, then we are to calculate the mean and the standard deviation for the probability distribution. And so, of course, we'll be using the formula for mean and standard deviation for probability distributions, not the formula for the mean and standard deviation related to the binomial probability distribution. So be careful, sometimes people confuse those two because they're both covered in this chapter. However, this one involves the table data, so we're going to do like the x squared times p of x and the x times p of x type work to get the mean and standard deviation. But before we do that, we have to confirm that this column adds up to 1. So let's check to see if those probabilities do add up to 1. So 0.125 plus 0.375 plus 0.375 plus 0.125, you can see they do add up to 1 in fact. Okay, so now that we know they add up to 1, okay, so now that you've added this column up and confirmed that they add up to 1, you just want to make sure that there's nothing unusual here. So just make sure there's nothing unusual in the probability column. So make sure there's nothing that's over 1 or negative. Those would not be acceptable probabilities. Okay, assuming all that's true and they add up to 1, then we do have a probability distribution. Let's go ahead and work out the mean then using our standard approach. So I've copied all the data down here, and we're going to begin to work out the mean then. The first step you want to do to get the mean is just multiply x times p of x. So every value in this x column gets multiplied by the p of x column. So 0 times this is 0, 1 times this is 0.375, 2 times this number gives you 0.75, and then if you have 3 times 125, you get 0.375. Okay, so there are the values multiplied out. We are to add this column up in order to get our mean. So the mean is going to be equal to the sum of this column. So if we add this column together, we end up with our answer for the mean. So adding this all up, coming down here, we end up getting the answer 1.5. So just use your calculator to sum these together. All right, so once we have that, then we're going to first square all the x values. So I like to do that right next to the x column. So I do x squared here, and I square them. I'd say 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. And then what I actually do is I actually go ahead and I cross out this column. I cross it out so I don't confuse it and accidentally use it. So I make sure I cross it out, so now I have to remember that my next calculation is x squared times p of x. And what I'm going to do is literally go from 0 times this, which is 0, and then 1 times this number, 0.375, and then 4 times 0.375, and so we continue on down the line. So that's going to give you 1.5, and then the last number is 1.125. So again, that's 9 times 0.125 is 1.125. All right, so we have our values in this column. We have to sum this column up to get our answer down below, this number here. This number that we're going to get here is going to be called the summation of x squared times p of x. Again, why is it x squared times p of x? Because that's the name of this column here. So we're just summing that. We get the summation of x squared times p of x, and that's a number we're going to need in order to be able to calculate our standard deviation. So I'm going to quickly add together that x squared p of x column, right? So it'll be 0 plus 0.375 plus 1.5 plus 1.125. When we're done, we get the sum 3. So we know that adds up to 3. Now this is going to be used in the formula. The formula is sigma is equal to the square root of, we're going to take this quantity, the summation of x squared times p of x, minus the mean quantity squared, so the mean squared. So we'll have the square root of, this whole quantity is just the number 3, right? So 3 minus 1.5 squared. Let's work that out in our calculator and see what we get. So I have 3 minus 1.5 squared. And we get 0.75, and if we take the square root of 0.75, we get 0.866. So 0.866. So that's our standard deviation, and that's our mean.